in an ionic compound, you're going to have at least one element which is a metal and at least one element which is a non-metal. And depending on where we find those elements in the periodic table, that's going to affect the charge on the ions, which is then going to affect the formula that we come up with. So, everything that's in group 1, this first column here, is going to form ions with a single positive charge. So I always say to my classes, when you go into the exam, you're going to go in feeling really positive, feeling really prepared, and because you feel so positive, in the top left of your periodic table, you're going to write a plus sign. And then you're going to feel really, really good about the fact that you've done what I've told you to, so you're going to feel even more positive. So in the second column, you're going to write 2 plus, because all of the elements that are in group 2 are going to make ions with a 2 plus charge. And then likewise, in group 3, we form a 3 plus charge. Group 4 we don't really think about, and then we start to go backwards. So we go 3 minus, 2 minus, minus. And obviously our group 0 don't tend to form ions because they already have a full outer shell, they're already stable. So personally, I find it quite helpful to have a visual representation of this. So let's have some ions. Okay, so I've got here an ion from group 1, an ion from group 2, an ion from group 3, and then from group 6 and group 7. So what you have to remember when you're trying to come up with the formula of an ionic compound is that the overall compound will not have a charge. It's made of positive ions and negative ions, but they are in proportions such that the overall positivity is balanced out by the negativity. And so we have to have the same number of positive and negative charges. Now, obviously, magnesium has a charge that is twice the size of lithium. So when magnesium bonds with something, we're only going to need half as much of it because every ion has got a charge that is twice as big. So let's see what this looks like in practice. So let's say I want to know what the formula will be of lithium fluoride. So lithium is in group 1 and it has a single positive charge on its ion, and fluorine is in group 7, so when it makes fluoride ions, they have a single negative charge as well. Now you can see that those two ions have charges of the same magnitude, they're balanced, and therefore we don't need to do anything else with them. So the only other thing we need to mention is that when we write the formula of this compound, we're not going to include those charges. So the compound itself is just lithium fluoride, just like that. Now, if I want to make lithium oxide, my lithium has still got a single positive charge, as we said. But when oxygen forms oxide ions, they have a 2 negative charge because oxygen gains 2 electrons when it forms ions. So therefore, my single positive charge on the lithium ion is not enough to balance out this oxide ion. I'm actually going to need a second lithium ion so that they balance. And you can see that now we've got the same amount of positivity and negativity. So I write that as Li2 to show there are 2 lithium ions, and then an O for oxygen. So like we said, when magnesium bonds, because it has a 2 positive charge, we only need half as much of it compared to lithium to balance out charges. So if I take away my lithium ions, I can substitute in magnesium, and you can see that because magnesium is 2 plus and oxide is 2 minus, they just balance out straight away. So we can have MgO. But if I were to go back to my fluoride ions, because the fluoride ion only has a single negative charge, that is not enough to balance out the positive charge on the magnesium. So we're going to need 2 of them. Well, if we go as far as group 3 and we get to aluminium, aluminium has a 3 plus charge. And so it's actually going to need another fluoride ion to balance it out. And we get to AlF3. But we can make things really complicated for ourselves if we go for aluminium oxide. Because now I've got a 3 plus charge on my aluminium. I've got a 2 minus charge on my oxide. And if I add another oxide ion, I've now got too much negative charge. So I have to add another aluminium ion. Sorry that I can't quite fit this all on the screen. And then I've got too much positive charge, so I add another oxide ion. And so what I end up with is Al2O3. And then as one final example using these, just in terms of how you would write it, we've already said that magnesium has got a 2+ charge. Now you do have what are called compound ions. So compound ions are things like nitrates, or sulfates, or carbonates, where you have multiple atoms and then a charge that applies to all of them. So this is 1 nitrogen atom, 3 oxygen atoms, and the whole thing has a single negative charge. So again, that's not enough to balance out my 2+ on the magnesium, so I'm going to need 2 of them. And this is when we start using brackets to say we've got 2 of the whole ion. So we would write this as Mg brackets Na3 brackets 2. Now that's all well and good, but you might be thinking, well, I'm not going to have a bunch of pieces of coloured card in my chemistry exam, so thanks, but this doesn't really help me. Well, firstly, it is completely fine if you want to draw little boxes on the side of your exam and draw little brick walls. You go right ahead, your examiner is not going to mind or care. But also there are some other ways we can do this. So, there's a method called the cross method, and it works a bit like this. Say I take, aluminium is probably the easiest one to do it with. I have Al3+ ions, which I know because it's in group 3, and O2- ions, which I know because it's in group 6. And what the cross method says is I'm going to take this number up here and put it down here, and this number up here and put it down here. So the 3 has gone next to the oxygen and the 2 has gone next to the aluminium. Now that method works beautifully for aluminium oxide because we've got charges up here that have numbers in them. So the first thing you need to know if you're going to use it is that if there's just a plus or if there's just a minus, you have to imagine that there's a 1 there. So say for lithium oxide, lithium makes single plus ions, oxide makes 2 minus ions, so the 2 goes down here, and what's going down here is kind of an imaginary 1. So I have my 2 next to my lithium, and then the same imaginary 1 that was up there is now down here. The other place you really have to watch out for it, though, is where you have something like magnesium oxide. So magnesium is 2+ ions, oxide is 2- ions, and what the cross method would say is that we're going to put this 2 down here and this 2 down here, and I would end up with Mg2O2. Only problem there is that for ionic compounds we always want to give the simplest possible ratio, and obviously Mg2O2 can be simplified to be MgO. So just watch out for that one. The cross method is really useful, particularly if they've given you the formula of an ion that you've never heard of before and you're just trying to do things quickly, but just make sure that you are simplifying your ratios at the end.